Hi, and welcome to the mastery project for Jesus Gonzalez. Let's get straight into it. So this is our thing that we have to do. So the first question, number one, AI. AI asks us to draw a free body diagram for object number one. We know that object number one is at rest. It's not moving up, it's not moving down, it's not moving left, it's not moving right. But we also know that object two is exerting force on it because it's on top of it. So, what's our free body diagram going to look like? It's asking us to do a dot. So we're going to do a dot. First of all, as any free body diagram should have, F of G, because gravity will always be there unless it is clearly stating that it's not going to be there. Another thing that we need to note is that because it's being placed below an object and the object's on top of it, we can add FA because the force is being applied on top of it. Like always, there's a force natural. And yeah, that's it. That's all there is. It's not moving left, it's not moving right. This is your diagram. Moving on to our next question. Let's see what it says. On a dot that represents block 2, draw and label the forces, not the components, exerted on block 2. Each of the forces must be represented by a distinct arrow on it. So for AII, we have block 2, which is this one, being placed on top of block 1 and on the rope. So one thing we need to note is that it's not going left again, it's not going right, it's not going up, it's not going down. It's completely staying flat. So, excuse my dog, sorry. So like always, force of gravity, F of G, and since it's on top of the surface, we can think of it as just staying still. So it would be on top, F of N. So that's for double I. On to the next one. So let's say consider a scenario where mass of M3 of block 3 is greater than the mass of M2. Without using equations, make a claim about the motion of block 3 in terms of unbalanced and balanced forces. Oh, this is after you remove block 1. Very important. So without using any math about it, let's think about this logically, right? In the start, they said there was no friction. When we first started this equation, they said no friction at all. So we have an object with no friction. We take away the block, and we have one force only, which is the tension here and the gravity here. Two forces really, tension and gravity, pulling on an object. So since there's no friction, there's nothing fighting it back. So even if this is like, let's say, super ridiculously tiny, because it's the only thing pulling it down this way, the object's gonna move that way. Doesn't matter, it might move at the slowest rate possible. This might be the heaviest object in the world and might zoom, but it will move. So that's number 3, number BI. So B2, BII, asks us to define an equation for the acceleration of block 3 for any, basically write it out, we'll show some math. So acceleration, we're trying to find acceleration. So what we can do for the acceleration is we can have everything on the S of G. So the sum of everything on the S of G over the mass. So what's the sum of everything on the S of G? Well, we know we have the mass of this one, because this is the thing pulling it down. So this is also equal to tension. That's the only thing pulling it down. So that's the tension. So A is equal to M2 times gravity, because gravity is pulling it down, over the masses, which would be the mass of m2 plus, because there's two masses, remember, the mass of m3. Yeah, that's your thing. Because yeah, we have that. Let's see. C. Describe in what way your answer put into part II is or is not consistent with your claim in part BI. It's consistent. It's consistent because what we said was this M2 and gravity was going to be pulling us down, and it's going to be pulling it down, and right here it just says this is going to be pulling all of it down. Yeah. Let's see, is there any more? Oh yeah, part D. The final part. So draw a graph of the whole thing. They said the first one is V over T, and then the second one is A over T. All right. So velocity. Well, we can just, it's going down, so we can make this go down because the gravity is going down. So really, well, me personally, I interpret it as it going down. It's not accelerating. Well, it's not accelerating, it's just going at a constant velocity. So really it'd just be like a straight line down. This is negative. This is negative, this is positive. And then there's no acceleration, it's just constant. It's just constantly negative. So again, this is negative, this is positive. So there's no like accelerations, it's just constant. Bada bing, bada boom. That's it. That's all there is. Boom, bam, bam. Is there any more? No, there's not. Thank you for listening to my video.